Hello, this is Rocco Garcia, and this is Lab 1 for Physics 2211, Constant Velocity. This is the table of contents, starting off with an introduction. So, first off, I'm going to talk about some key concepts, starting with Newton's first law of motion, which states an object will not change its motion unless acted upon by an external force. And therefore, an object moving with constant velocity has no external force acting upon it. So with that in mind, if we take a look at our velocity and position update formulas, in the velocity update formula, V final is going to equal V initial because our net force is going to be 0 in this instance of perpetual motion. And our position is going to update incrementally because our velocity is going to stay even the entire time. And the experiment is going to measure the motion of an object, in this case my skateboard, moving with constant velocity. The system is the skateboard, the surroundings are the earth and the ground, and my initial conditions, the position is going to start at 0. The velocity, which I calculated to be 2.6 meters per second, and it spans over 1 second. This is the video we're going to be analyzing. That's my skateboard. And in Tracker, I marked every position frame by frame to analyze the motion of the skateboard, which ends up being fairly even. And I'm going to compare that with this code on GlowScript, measuring the ball's initial position, which I set at 0, its initial velocity, which I set to 2.6, and every time step is going to be 0.05, which, as you can see in Tracker, that's every frame increases by 0.05 seconds. So with that, I implemented the velocity update formula, which we know F net is going to stay 0, so that's not going to change, and the position update formula just as it's written, and every loop is going to span delta t, which is 0.05. And when we run this is our chart, and it tells us every single time step. And here we see every observed position compared to the calculated position in GlowScript. There is very little difference between observed and calculated, which means it was a pretty good experiment. There's little variation, but as you can see, there's a little bit of variation of the observed position, and this could be possible sources of error, like Tracker input. As you can see, it isn't necessarily perfect, so that could be adding to that, and measurement error and not calculating over a long enough period of time. Something we can ask is, what if I were to flip the axes and the positive x direction was interchanged with the negative x direction? So we could see that if I pull up this coordinate axis, I set the left being x positive because my skateboard is moving to the left, but if we change that really fast, we can see that it's the same plot, it's just going down. So that's pretty obvious because it's going, instead of going from starting from 0 and going positive, it's starting from 0 and going in the negative direction. So the results are the same, they're just flipped. And what does it mean? Is it possible to say how many pushes and pulls, how many forces are added together to give 0 net force in the case that you observed? So in the y direction, we can say that the net force is 0 because the only thing acting on the skateboard is the force of gravity and the normal force of the ground, which in the end cancel out, it's staying even in the y direction. And in the x direction, ideally it would be no net force to keep constant velocity, but in real life there could be friction, um, the friction within the bearings and the wheels. So there's too many factors to realistically give an answer of how many pushes and pulls are affecting that. And thank you for watching.